Good morning, this is Kasturi Day. I'll discuss this language of chemistry, this how to balance a chemical equation. This chapter is according to ICSE syllabus, class 8, okay? So I'll discuss today how to balance a chemical equation. So for balancing a chemical equation, there are certain steps. So we need to follow that, okay? So first, set an example. Let us set an example that we burn magnesium in presence of oxygen. So what will be the equation for this? Uh, the word equation will be magnesium plus oxygen, that is magnesium burns in oxygen to give magnesium oxide. So the reactants are magnesium and oxygen, and the product formed is magnesium oxide. So magnesium and oxygen, magnesium plus oxygen gives us magnesium oxide. That will be the word equation. Then after we insert the formula, the skeletal equation will be Mg plus O2 gives us MgO. This is a skeletal equation because it's not balanced. So before balancing it, for balancing this equation, first step we need to follow is the number of atoms of each element on either side is counted. That is, on the reactant side and the product side, the number is counted. The number of atoms is counted. The convenient way is to start balancing with the compound that contains the maximum number of atoms. Okay, so the number of atoms on each element on the reactant side, let us take, so because here in the reactant side there is maximum number of atoms. So from the reactant side, magnesium is number of atom is 1, and for oxygen it is 2, and on the product side the magnesium atom is 1 and oxygen is also 1. So one extra atom, oxygen atom, is present on the reactant side. Okay, this is step 1. Then step 2 is the product is multiplied by 2 on the product side. That is product which is formed, that is product side, is multiplied by 2, as there are 2 oxygen atoms present on the reactant side. So to balance it, first in the second step we multiply the product by 2. So the equation will now come as like this, that is Mg plus O2, that will be equal to 2 into MgO. Now what happens on the reactant side? Mg is equal to 1 and O is equal to 2. And on the product side it will be Mg is equal to 2 and O is equal to 2. This means one extra atom of magnesium is present on the product side. Okay. Now in the step 3 condition, what happens? The magnesium atom on the reactant side is multiplied by 2. Okay, there was one deficient atom on the reactant side, so we multiply the magnesium atom on the reactant side by 2. So it will come to like this, the 2 into Mg plus O2 will give us 2 into MgO. Now on the reactant side it becomes Mg is equal to 2, O is equal to 2, and on the product side Mg is equal to 2, O is equal to 2. Now this equation is balanced. So final balanced equation will be 2 Mg plus O2 will give us 2 MgO. Now, one thing is to be noted, that the number required to balance the atoms of a molecule that should never be written, should never be inserted in between the formula or written as a subscript, as it will change the formula. You cannot write the number to balance the equation. You will never ever write, don't ever write this number in between the formula, or you should never write as a subscript. Okay, because that will change the formula. For example, the reaction of hydrogen with oxygen to produce water will be, the word equation will be hydrogen plus oxygen, that will be water. Okay, inserting the formula, it will be, the skeletal equation will be now H2 plus O2 will be H2O. See here on the, as in the step 1, as we need to count the atoms on both the reactant side and the product side. So the reactant side, the hydrogen atom is 2, oxygen is 2, and the product side, hydrogen atom is 2 and oxygen is 1. So one extra atom of oxygen is present on the reactant side. Okay, so to balance the equation, we will never write this 2 on the product side as it is, as its subscript, or in between this H2 or O. Okay, so for this we will work in the step 2. According to the step 2, the product side will be multiplied by 2. The equation now comes as to H2 plus O2 will give us 2 into H2O. Now it is that on the reactant side is H is equal to 2, O is equal to 2, and H is equal to 4 on the product side, and oxygen O is equal to 2 on the product side. So 2 extra atoms of hydrogen are present on the product side now after this step 2 condition. Then according to step 3, we will multiply by 2, multiply this hydrogen on the reactant side by 2. That means 2 into H2 plus O2 will give us 2 into H2O. Now in the products, in the reactant side, on the reactant side, H is equal to 4, O is equal to 2, and on the product side, H is equal to 4 and O is equal to 2. So therefore the final balanced equation will be 2H2. That means it is balanced. Okay, so in the final balanced equation will be 2H2 plus O2 will give us 2H2O. Okay, again another example is that reaction of iron 2 with hydrochloric acid. See, iron plus hydrochloric acid will give us iron 2 chloride and hydrogen. That will be a word equation written in words. Now inserting the formula, Fe plus HCl will give us FeCl2 plus H2. That will be the skeletal equation. Now according to step 1, we'll count the atoms on both the sides, reactant as well as this product side. Okay, the reactant side, iron is equal to 1, hydrogen is equal to 1, chlorine is equal to 1. Product side, iron is equal to 1, chlorine is equal to 2, hydrogen is equal to 2. Therefore what we'll do that, therefore we see that both hydrogen and chlorine have an extra atom on the product side. Okay, now according to step 2, we will multiply the HCl which is present on the reactant side, that is hydrogen chloride that is present on the reactant side, we will multiply this by 2. So what will we see that after this multiplication, we will see that Fe plus 2 into HCl will give us FeCl2 plus H2. Then what after counting, we will see that Fe is equal to 1, H is equal to 2, and Cl is equal to 2 on the reactant side, and on the product side it will be Fe is equal to 1, Cl is equal to 2, and H is equal to 2. That means the number of the atoms on each side, that is reactant and the product side, are equal. Therefore it's a balanced equation. So final equation will be Fe is equal to Fe plus 2HCl will give us FeCl2 plus H2. Okay. Next, another example is zinc plus sulfuric acid will give us zinc sulfate plus hydrogen. Okay. So after inserting the formula, we will see that zinc Zn plus H2SO4 will give us ZnSO4 plus H2. That will be a skeletal equation. So now we balance the equation. First we count this reactant side and the product side, number of atoms. Reactant side, Zn is equal to 1, H is equal to 2, S is equal to 1, O is equal to 4. Then on the product side, we will see again Zn is equal to 1, H is equal to 2, S is equal to 1, O is equal to 4. Therefore, we can see that number of atoms on both the reactant side and the product side are equal. So, the skeletal equation here in this equation is a balanced equation. Okay, so it is like this Zn plus H2SO4 will give us ZnSO4 plus H2. So, the skeletal equation is a balanced equation in this case. Okay. Next is information which is conveyed by a balanced chemical equation. What information do we get from this balanced chemical equation? It tells about the reactants which take part in a chemical equation. It tells about the products which are formed during a chemical equation. It tells us the number of molecules of each reactant which is taking part in a chemical reaction. Tells us about the number of molecules of each product formed in the chemical reaction. Okay, it tells us about the relative atomic mass of the reactants which is taking part in the chemical reactions and the product form. See, it tells us the what are the reactants which are taking part in the chemical reaction. It tells about the products which are formed in the chemical reaction. It also tells us the number of molecules of the reactant side and also the number of molecules on the product side. Okay, it also tells the relative atomic mass of the reactants, also the which is taking part in the chemical reaction, and also the relative atomic mass of the products which are formed. Okay, from this chemical equation, balanced chemical equation, we get this type of information. Okay, now what are the limitations of a chemical reaction? The limitations are the physical states of the reactants and the products. That is, whether they are solid, liquid, or gas, we cannot identify from this chemical equation. The concentration of the reactants and the products, how much concentrated it is, we don't know from these reactions. It cannot be uh, uh, we cannot get the idea from this chemical equation. The time taken, what is the time taken to complete this reaction? The rate at which the reaction is proceeding, then the heat changes during the reaction, whether it is absorbing heat or it is giving out heat. So we are not able to get the information of these things. Even the temperature, such as the temperature, pressure, catalyst, etc., which are affecting the reaction, we are not able to get the information from this chemical equation. Even the nature of the reaction, whether it is a reversible reaction or an irreversible reaction, we are not able to identify these things from this chemical equations. So for this, we need to make the chemical equation more informative. Okay, so I will discuss these two things in my next video. A very short thing is left, this information about how to make this chemical equation more informative. So I will discuss this one in my next video. Please go through this. If you have any doubt, please do let me know. Write in the comment box. Go through the videos which I'm posting it, uploading it. And if you are liking it, press the like button and also share with your friends. Okay, so that they can also be benefited from this. And do subscribe to get the notification of my next video. Thank you for watching. Have a good day.